Okay, so the next concept that I want to cover is network separation and VLAN management, basically ways to secure and separate network segments. So, a VLAN, or a virtual local area network, can also be referred to as a broadcast domain. And what a broadcast domain is, when we have a switch, if a broadcast is sent from a host on that switch, it goes in one port. Let's say it goes in port 1. And in this example, we have a 48-port switch. If there's a computer attached to port 1 and it sends out a broadcast, that broadcast is going to go out every other port on the switch, okay, because we have one big, giant broadcast domain. We want to separate that traffic, all right, if at all possible. If we have different types of computers attached, whether they be PCs, servers, IP phones, what have you, different areas of the network, maybe different groups, okay, HR, finance, accounting, so on and so forth. We want to separate those things out if possible to reduce traffic, reduce collisions, and also increase security. All right, so let's say we have this 48-port switch. If we have all of these different types of PCs attached to that switch, again, you can see in each of these logical separations, we have some servers, we have some PCs, we have some IP phones, which is designated by the globe with the phone next to it. You can have any number of different types of devices attached to the switch. Initially, it's all set up as one. We don't really want that, all right? So we want to basically segment those out and go onto the switch and configure any number of those ports. We can group them however you like into different VLANs or virtual local area networks. So that way, as I said, it separates the traffic. It creates separate broadcast domains so that if, for instance, on VLAN 20, PC 1, if it sends out a broadcast, it's only going to come back out of the ports within VLAN 10. All right, so it makes it much easier, much more secure, and we can create security by what's called segmentation. Separating the VLANs, at that point, we then need a layer 3 switch or a layer 3 device. It could be a layer 3 switch or it can be a router to access other virtual local area networks. Okay, it's just like as if we had physical LANs, right? Physical local area networks. One network cannot contact another network unless there's a router in between. Now, what we can use is something called 802.1q or VLAN tagging on those interfaces, on the router interface or the switch interfaces. All right, so we don't necessarily have to have physical interfaces on the routers themselves. All right, so in our example here, we have our internal network and our external network. The switch and the router that you see on the internal network, we don't necessarily have to have individual devices or individual interfaces rather on that router. We could have 3 or 4 VLANs on that switch. We can have one physical interface on the router, but we can then create what's called sub-interfaces. All right, that's where the 802.1q comes into play. We can set up 3 or 4 or however many sub-interfaces that we need on that router, so that way it knows VLAN traffic coming in on VLAN 10, go out sub-interface 10. Traffic coming in on VLAN 20, go out sub-interface 20. All right, so basically, if we look at it in this fashion here, we have a router interface. Okay, in this case, we have 2 interfaces that are trunked together. And we have all of our VLANs, okay, VLAN 10, 20, 30, and 40, like we had in the previous example. Well, we can basically aggregate those 2 links together, trunk them, and then on the router interfaces themselves, we would just create, on the interface to the left, we would just create sub-interface 10 and 20. On the sub-interface on the right, or the router interface on the right, we would create 2 additional sub-interfaces for 30 and 40. So that way we can pass that traffic without having to have separate interfaces for each individual VLAN. Okay, so just so you're aware, 802.1q, if I were to bring up the interface or the terminal session for that router on a Cisco router, I would then go into the interface and I would create an IP address, not for the interface itself, but for the sub-interface. So you see where I say gigabit Ethernet 1/0/0.10. I'm basically saying on fast Ethernet interface 0, I'm going to create a sub-interface .10. All right, it's a description of the sub-interface for VLAN 10. And again, I could name that whatever I want. If you have a VLAN called 10, you should name your interface .10, VLAN 20, .20, etc., etc. That way it's easy to recall and look at a glance and tell what VLAN that sub-interface is associated to. So you give that sub-interface an IP address, 10.0.10.1 in this case, with a subnet mask of /24 or 255.255.255.0. And then we're going to set the encapsulation type to .1q 10. On the second interface, or the second sub-interface rather, again, it's the same physical interface. You'll notice it's /0, but instead of it being /0.10, we'll put in /0.20. Okay, we're creating a separate sub-interface called .20. Again, description of a sub-interface for VLAN 20. IP address 10.0.20.1. All right, so we're creating separate virtual local area networks, or we're associating those interfaces rather with those separate virtual local area networks. Encapsulation .1Q20. So that way we're making sure that we separate out the traffic on that single interface. So when traffic passes over those cables going into that router interface, it knows which sub-interface to pass it through, and of course which VLAN to route it to. Okay, so let's take a look at a real-world example of how a hacker could gain access in this environment. So let's say, for instance, we have our two wireless access points that we have here. Well, if someone wanted to come in and, again, a malicious individual, a hacker, etc., they could set up what's called a rogue access point, and they could issue a denial of service against our existing wireless access point, basically take it offline or make it so that it can't respond to requests. They could put a wireless access point using something called open authentication, which means there is no password required. The laptop, whoever's sitting on that laptop, they would connect to that wireless access point, otherwise known as an evil twin, quote unquote. Okay, so that's a term you should be familiar with, or you should remember. We'll cover it in more detail later. But an evil twin basically is there to fool someone connecting to the network. So they think they're connecting to the wireless access point. So even though they have credentials to connect to the legitimate wireless access point, that's going to be DDoSed, so they can't connect. So they're going to connect to the evil twin. It's using open authentication, which means they don't need a username and password to connect. So they're connected. And if we are in control of that wireless access point, of that evil twin, we could set it so that it pops up some type of authentication message. So the user sitting at the laptop would think, something must have happened. It's prompted me for my credentials. And they'll go ahead and put in their username and password, or they'll do that several times. And we just keep putting up fake messages until we capture enough information that we can be pretty confident that we have what we need off of that user. All right, so then we can just disconnect and off we go. So in that case, we could very easily compromise that communication. We could capture everything, or we could actually have it connected to the network and let them pass through and actually connect, and we could just sit there and monitor everything that they do. All right, as that communication passes through the wireless access point. So just be advised that those types of things are in fact possible. You could be sitting at a coffee shop and someone could do something similar to that. It doesn't necessarily have to be in a business environment. It could be, anywhere that you would connect using a wireless access point.